In this lesson, you will learn about voltage, current, and resistance. When you know these three concepts, it's much easier to understand how and why a circuit acts like it does. And it becomes much easier to understand each component in the circuit. Looking at the circuit before knowing this and after learning this could be like night and day. Here's a beautiful image that illustrates voltage, current, and resistance, and how they work together. Current is what's flowing through the circuit. It's measured in amperes, and it's illustrated by the green guy here. He's both being pushed and held back by the two other guys. The yellow guy who's pushing the current through the circuit is the voltage, and it's measured in volts. The red guy on top is the resistance. It tries to resist the current from flowing freely through the circuit, and it's measured in ohms. Let's look at the resistance. Here's a very common component, the light emitting diode, also called an LED. The LED is a very common component for creating light. It's like a modern light bulb. But if you connect it directly to a battery, too much current will flow through the LED and it will die. The solution is to place a resistor into the circuit. The resistor is a component that has a certain resistance, and it reduces the current in the circuit so that the LED doesn't break. All materials have resistance, by the way, even wires, but usually the resistance in wires is so low that we can ignore it for most circuits. It doesn't matter if you place the resistor before or after the LED though, the resistor will reduce the current in the whole circuit. Now let's look at voltage. The most important thing to remember about the voltage is that it's always measured between 2 points. You can measure voltage with the multimeter. If you have a battery of 9 volts, that means that the difference between the plus terminal and the minus terminal is 9 volts. Or more exactly, the voltage on the plus terminal is 9 volts higher than the minus terminal. And because of this, the minus terminal is often called 0 volts. Let's look at the LED circuit again. When we look at the circuit, we often look at the voltage over a component, or the difference in voltage between the two sides of the component. And this is called the voltage drop of the component. An interesting thing to notice is that if you add the voltage drops of all the component in a circuit like this, you will get the same voltage as the battery voltage. Now let's look at current. Current is what flows through the circuit, from plus to minus, and often the current is represented by the capital letter I. Current is made up of electrons. And as a side note, electrons actually flow from minus to plus, but the conventional way of talking about current is from plus to minus. It doesn't really matter which way you use, because your calculations will be correct as long as you stick to one direction all the time. But since the conventional talking about current is from plus to minus, that's what I'll be using. In a circuit like this, with only one path for the current to flow, the amount of current will be the same anywhere in the circuit, because there's nowhere else for the current to flow. The current that flows out of the plus terminal will be the same as the current that flows through the LED, and the same as the current that flows through the resistor, and the same current that flows back into the minus terminal. So, to sum it all up, current is what flows through the circuit, voltage is the force that pushes the current through the circuit, and the resistance resists the current from flowing freely.